Today we are first going to be going over a one-sample proportion test. This is used to assess whether a population proportion is significantly different from a hypothesized value. The formulas on the left are given on the AP test. When combined, they form the formula given on the right, which you may notice follows the basic format of a simple z-test. It isn't mandatory to give the generic equation of the two proportion, but if you do, be sure to specify that the first proportion is a statistic and the second is a parameter using p-hat and p-null. The standard deviation should be calculated using the null probability as well. We first start off with the state part of our sample test, which must cover both the null hypothesis and the alternate hypothesis. The null hypothesis is a statement that signifies no difference between two groups or the original claim for the question. The alternate hypothesis, on the other hand, is what you are trying to find evidence for. This can be either one or two-sided, as certain problems may ask you to test whether a certain variable is less than null, and others simply want you to test whether there is any deviation from the null. You should also provide your alpha level, the p level at which you will reject the null hypothesis. 0.5 is usually what you will be using. Unless the problem states that all conditions are met, you will need to make sure that your sample comes from a random sample or an experiment where treatments are randomly assigned, and that the sample is less than 10% of the population. You will also need to make sure the product of the sample size and the probability for the null hypothesis, as well as the product of the sample size and the probability that the null hypothesis is untrue, is greater or equal to 10. In other words, the sample must include at least 10 successes and 10 failures. For the due proportion, plug in values from the formula earlier to get your p-value. Though you can write down the general formula, it is not necessary. Note that the formulas on the left only give the standard deviation of the sample. You'll still need to plug the value you get from that into the standardized test statistic to get your p-value. The p-value means that the likelihood of randomly getting a sample is extreme or more as the one used as p, given the assumption that the null hypothesis is true. Additionally, keep in mind that the p-value only gives one tail. If you need to prove a simple inequality, you will need to multiply your test statistic by 2. When you conclude a significance test, compare your calculated p-value to alpha. If your p-value is smaller than your significance level, then the null hypothesis is rejected. Otherwise, if your p-value is larger than your significance level, there will not be enough evidence to reject the null hypothesis. Keep in mind that you should never say the null hypothesis is accepted. Just because you know the alternate can't be accepted doesn't mean the null hypothesis is true. To find a p-value for a categorical data significance test using an TI-83 or 84 calculator, first press the stat button, then one prop z test, and enter in the null hypothesis, number of successes, sample size, and alternate hypothesis. Then press enter to get your p-value. For the TI-89, in the stats list editor, press second, then F1, and choose the one prop z test. Then in the dialog box, enter the same values in the respective places and press enter. Again, the formulas on the left are given on the AP test. The formula given on the right shows a calculation using a combined proportion shown in the bottom of the image on the right. Remember to put p-hat instead of p if you write out the generic formula in the do section. Technically, z would be equal to p-hat 1 minus p-hat 2 minus the null, but in almost all cases it's just going to be 0, which is why you don't see it in the second image. The special case given by the AP test is simply the one above, where proportions are assumed to be the same and therefore factored out. The state portion of a two-sample test is similar to a one-sample test, but involves two proportions. Possible hypotheses combinations are given in the bottom right image. Remember that your alternate hypothesis is two-tailed. You'll need to multiply your test statistic by 2. The planned portion for a two-proportion z-test is almost the same as that for a one-sample test, except for the large counts condition. In this case, there must be more than 10 successes and failures in both samples, or more than 10 as calculated using the pooled sample proportion, given by dividing the number of total successes by the total observations. Note that the pooled proportion cannot be used to create a confidence interval. The due portion of the two-sample test is the same as that for a one-sample test, just with a different formula. Keep in mind that the formulas on the left only give the standard deviation of the sample. You'll still need to plug the value you get from that into the standardized test statistic to get your p-value. Finally, remark on what the p-value indicated for the null and alternate hypothesis. The conclusion for a two-sample significance test follows the same procedure as the conclusion for a one-sample test. To perform a significance test for a difference in proportions on the TI-83 and 84 models, first press stat, then test, then 2-prop z-test. Input the first number of successes, the first sample size, and the second number of successes, and the second sample size. Select your hypothesis and click calculate. For the TI-89 in the stats list editor, press second, then F1, then 2-prop z-test. Input the same values and press calculate. I have also listed some problems below that will help you practice more.